So earlier, Brian spoke about how we can use 2PC to do or how we can use 2PC to do things. And like my belief is that like we're at a point with 2PC today where we were with ZKP like 4 or 5 years ago, where it's just becoming possible to start building things with it. So my talk today is called 2PC is for lovers, and I thought it was okay. And the first question that I have for you, did you ever fall in love with your best friend? And you think about your feelings for this person in the context of your relationship, and you feel like you should tell them how you feel, but also you're afraid to tell them how you feel because you don't want to damage the friendship that you cherish and that they cherish. So you think about this for a long time and you feel sort of stuck and confused. So you start to study cryptography. And the first thing you do is you learn about zero knowledge proofs. And you learn that like zero knowledge proofs are like individual things, that you can make a proof that you know something and someone else can make a proof that they know something, but it's difficult for you, or it's impossible for you to like coordinate with someone else. Like, put another way, zero knowledge proofs so that you prove secrets that you know, but they don't let you prove about shared secrets. So here's an example of like ZKP for like this love problem. So you have like 2 zero knowledge proofs where like you and your best friend make these proofs, and the problem is that you always have this first mover problem. Like, I can make a proof and I've somehow convinced my friend to make the proof as well, and they suspiciously agree, and we make the proofs, but like there's always this first mover, because do I reveal my proof first, or do they reveal their proof first? So it's always this kind of like first mover chicken and the egg problem when you try to build a system with ZKPs. But we can use 2PC to overcome this problem, where basically 2 people put their input, and then inside the 2PC we can have this like circuit that we can program and decide what it does, and then it produces an output. So let's take an example of the friendship 2PC. So like one person inputs love, the other person inputs friendship, and some magic stuff happens inside the MPC circuit, and the output is just friendship. And like you can think of like the truth table of this application is that like you can, like, if both people agree to love, then the output is love. If one person inputs love and the other person doesn't, then the output is friendship. So it's the same as like the Tinder swipes, that like you only match with someone if they also match with you. So there's less nervousness about what's going to happen. So this is friendship, and then here's what happens when the 2 people input love, and then this happens. So like we're gonna come back to this problem a little bit later. Like roughly the issue that we're at right now is that like we're able to do the 2PC, but it's difficult to convince your friend to do this 2PC, because asking them to do the 2PC is the same as like just telling them, basically. So we're going to come back to this later. We're going to come to some kind of reasonable conclusion about this, hopefully. But after you spend this time studying cryptography, you think that like, well, MPC is useful for other things too, that there's like a whole bunch of different people in the world who have similar problems. And one example of them is like with health data and hospitals. So let's take a look. So let's take an example of like the ZK hospital, ZK patient data. So let's say that we have a researcher who has sequenced like a lot of people's DNA, and they have this data set, and they're able to do research about their individual data set. And there's a hospital that has like a lot of patient information about like the diseases that people have. And like both of these data sets are independently valuable, but what would be more valuable is if we could merge the 2 databases together. Because if we can merge the databases together, we can map someone having a mutation to someone having a disease. And that will help us a lot with with the research. So the ZKP version doesn't really work, right? Because it only allows the researcher to talk about the mutations and the hospital to talk about the patient data, but it doesn't allow them to coordinate and work together. So let's take a simple example here of just like a table join, right? So the researcher has all of this like people's DNA, and they simplify the database to just be a mapping of someone's identity to whether they have a mutation or not. And basically, this mutation, we suspect that it's involved in a disease. So we want to build a data set so we can test this hypothesis. So we go to the hospital and we ask them to make a mapping of people's ID to whether they actually have this disease. And then what we do is both groups inputs their table into an MPC where it's encrypted. And we do this kind of like table join where we replace we take Alice has the mutation and we see that Alice has the disease. So we put those two together. And then we see that Bob doesn't have the mutation and doesn't have the disease. So we put those two together and we remove the identity and we build this like table instead, which is very useful for us because it will allow us to see like, well, does this correlation really exist between like people having this mutation and people having this disease? Cool. So like this works in general, but the problem is that like it's very specific, that we can do it for like a single mutation and a single disease. And like, but even once we publish this, it starts to leak people's information that like in the previous example, the database was provided as an output. But what we could do instead is have some like generic machine learning algorithm that happens inside. And we can do this too using like ZKPs. But the problem is again that we have this like coordination problem. It's difficult for groups to like communicate and coordinate with each other. So the researcher is able to make proofs about like the data that they have with their machine learning algorithm, and the hospital is able to do the same, but they're not able to work together. So another thing that we can do is we can put the AI model inside of the 2PC. So we can have the data be provided and encrypted and computed on in this like encrypted format. So we're able to ask more complicated questions. We're able to ask like, oh, well, this disease is actually not just based on this mutation. It's based on this mutation given you have like a certain amount of like nutrition in your diet, or it's based upon these other two mutations, or it's based upon like some hereditary thing, like patient history stuff. So like really our 2PC can become this really powerful like research tool. And like we can also like, basically the way that I think about this is that like with bio, the limitation is not computation. With like health research and science, the limit is not really computation, it's data. And like having access to data seems like it's going to be able to, like, we need to have a way to allow this research to happen without people's information just being shared with everybody. Another example of what we can do is we could do like a 2PC Kaggle. So basically Kaggle is this website where you enter into machine learning competitions. You can do some training, like someone publishes a problem with some data and you can train with that data to try and do well in that competition. Once you finish, you publish your model and they publish like a testing set and they just test your model against the testing set and then they decide who wins. And this is okay, but like the problem is that your model is very valuable to you, that like you spend a long time trying to improve it, and like their data to verify is also valuable. So it would be nice if we can do this inside a 2PC so that people are not able to share or lose their this is so that we're able to do like more complicated problems with more private data. Another concept is like this share your data concept. So like there's a lot of ways that you can donate your computer hardware to solve some problem. Like you can use to like fold it at home, where you're able to like help folding proteins using your laptop's computer power when you're not using it. Or you can help to search for Mersenne primes using like another algorithm. And like these work well, but like computation isn't really the limiting factor in our world. That in our world, like computation is very easy to make. Well, it's not easy, but it's very possible to make like exabytes and exabytes or terabytes, like just very good CPUs. But data is the limiting factor. So we could have the concept of like donate your data, where you do like a 2PC and your data is used to do some training or to do some evaluation based upon like an algorithm that's being worked on and approved by like millions of people sharing their data. So like what I'm trying to get at here is that there's this general problem of like the tragedy of coordination, where there's like the best example or the most visceral example is the friendship love question. I feel like this is something that like it is kind of like a part of the human experience, where you have this like problem of like you don't know whether to share or not. But like this problem comes up in a whole bunch of different places, that like you want to do some coordination with some people, but like you're too afraid to reveal what you want to do, because if you reveal, it's going to change the situation. For example, if you wanted to buy like a house or a company, even saying that like I want to buy this is revealing information that can affect the price. Yeah. Cool. And like you can expand this thought to think about like the tragedy of coordination with the concept of legitimacy. And, like, this is a quote from like an article Vitalik wrote a while ago, and it basically says that legitimacy is a pattern of high order acceptance. An outcome in social context is legitimized if the people in that social context broadly accept and play their part in enacting the outcome, and each individual person does so because they expect everyone else to do the same. But like the expectation is the thing that I think is really key to think about when you're thinking about coordination, that like your expectation of other people's behavior seems to really affect the world. So like 2PC can be a tool to check what other people's expected behavior is, so that you are able to like align on the you can sort of coordinate without revealing what you want to do. For example, like during the Enlightenment, people's views on transubstantiation was very controversial, but like a lot of people had very similar views. So using 2PC would be like an interesting way for people to coordinate without a whole lot of people getting burned. Yeah, so back to our original problem. So we have this like love problem where you're not sure, you feel like you're unable to share your true feelings with your friend who you're secretly in love with. And the secretly is an important part here, because if you tried to solve the problem using like a naive NPC, it would lead to your friend would figure it out. You know, like, can you think of a way you can ask your best friend to participate in this weird cryptography thing, where they have to like input whether they're secretly in love or not, without them becoming suspicious about like why you're asking them to do this? So the solution is that we need to do 2PC with everyone all the time. And this way you wouldn't need to ask them to participate. You could just like, they would already be participating. But we have to turn the inputs into like more general information. So like imagine a world in like 10 or 20 years when AGI is gotten to the point where like we each have this like AI assistant who is also like a personal agony aunt who helps you with like how you're approaching. They're like a counselor and a therapist. This is like this being that you have this deep relationship with, and it's been designed for a long time to very effectively advise and give you like emotional support and reassurance. And everybody has one of these. So one of the cool things we could do is that we could get we could get like you and your best friend's AI, and you put them into like this 2PC where you merge the two together, and we have some algorithm to like accurately combine these two sort of artificial consciousnesses together in a way that we're able to like ask the big questions about. This is where the lovesick friend is like, I explains their story and their 20-year journey of building a whole bunch of ZK and NPC tools, and the friend is just like, what's going on? And the output, or the joined transcendent consciousness, is just typing. It's coming soon, that reply. Yeah. And here is more. And this one is where the reply is just very confusing and difficult to understand. And I'm trying to get at that, like the transcendent AI would maybe not be really comprehensible to us. Cool. So the general idea of merging together these like AIs seems like it could be useful in a whole bunch of different contexts. That like really, there's been a lot of discussion about this narrative of like AIs being this sort of neutral arbitrator, but in reality, in order to have neutrality, you need to have the ability to be like honest and frank, especially in situations where things are kind of difficult to coordinate about. So I believe that like in order to have like truly neutral arbitrators, NPC can be really valuable. That like if you think about the world that we live in today, that like we've never had a neutral arbitrator before, right? Every arbitrator was like every arbitrator needed to know all of the things you wanted them to arbitrate about. So this seems like a really fun potential here. Let me give some other examples that are maybe a little bit more real world. Although being in love with your best friend is like the most real world thing that you can do. So one example is companies. So imagine that we have a world where like all of these companies have these 2PCs, and all of these 2PCs are constantly being executed to try and find the optimal thing to do. For example, a company could do this with their stockholders or their big stockholders and say, to try and find like at what point is it good for them to raise more money, or what valuation of the company would they need to give up to raise more money. And this seems like an interesting input, because you can just decide that like, okay, if it's more than this valuation, I will raise more money. If it's less than this, I won't. And you can just wait for like those circumstances to happen. And like, this is an example of a negotiation where you don't want to admit that you want to do this, because as soon as you say, it'll change the price of the stock of the company. Another example is that companies can do this with their employees, that you can have this kind of like neutral HR department where you're able to like communicate about like your work and your experience, and you will know that like your private information isn't being revealed, and it can also be like computed on in this like encrypted way. Governments and citizens is an interesting application. So like the simplest one is just have governments talk to their citizens and get feedback about like what they want in their environment, or what improvements they want to have. But other example is that like imagine that you're like an apartment owner in a building, that like you want to coordinate with the other apartment owners in the building, but like you don't want to admit that like, I want to sell my apartment, because if you sell your apartment, then if you admit that you want to sell your apartment, then the price of your apartment kind of changes, right? Because people know you want to sell, so they're like, I can try and get a better price. Like another example of this is that like you have an apartment where it's like the building is like the building is worth more than the sum of its parts, and if you can somehow coordinate with the rest of the people who own buildings or apartments in that building, you'll be able to get like a better price for like selling as a group as opposed to selling individually. But it's not really possible for you to coordinate this. And like we could go one step further and have this as like this kind of like city planning department where people are constantly trying to figure out like, I have this block of land, and this block of land, and we both want to sell, so we can combine and have like different planning permission, or I'm willing to sell this building as long as this other building is rezoned. And like you can have all of these like really complicated negotiations happening like in private, and in a way that like different people's inputs are hidden. Yeah. So like the conclusion that I'm tending to draw from this is that like there's a lot of what's called these like tragedies of coordination, that like there's all these times when you want to work together with other people, but you're not able to, because as soon as you admit that you want to work together or coordinate with the other person, you sort of lose something. You lose this kind of like negotiation position, or a friendship or something else. So this is the kind of situation where 2PC can be very powerful, and it helps us solve these kind of tragedies of coordination. In general, like we've been talking a lot about ZKPs recently, but like this is programmable cryptography, and like I thought it was important to share another example of cryptography that we think is going to become very impactful in the next few years. I think that right now 2PC is at a very important moment. It's about to become this tool that's practical to build things with, and we're going to be able to do some more 2PC experiments very soon. The third one is, if you love your best friend, you should probably just tell them if you can. But if you cannot, please, we need more help with 2PC. Okay, I think we have some slide for the Yeah, this is a slide for the Telegram group. You can have a question and answer session inside the Telegram group. It uses ZKPs, so you're not able to see who's asking what question, but you can see what questions are asked. Okay, so we have 3 questions already. The first question is, what are some of the complexities and differences going from 2PC to MPC with multiple parties? Cool. So this is a really nice question and something I wanted to touch on. So basically, MPC is or 2PC is a special case of MPC. MPC stands for multi-party computation, and 2PC is two-party computation. And basically, what we want to do, the reason why I say 2PC is because 2PC has this 2 of 2 security guarantee, which means that if two people, if in order for the thing to be broken, 2 people need to collude. And because it's just 2 people participating in the protocol, you have the same kind of privacy guarantees that you have with ZKPs and that we've come to expect in our programmable cryptography world. MPC can have this property too, that you can have 2PC, you can have 3PC where 3 of 3 need to collude. So this works well, but there's certain kinds of MPC, which is K of N MPC. And this is something that we don't really like the security guarantees of as much. And the reason for this is that if there's a lot of kind of cryptocurrency applications of this where people make this kind of encrypted Uniswap where you can trade on Uniswap privately, but if 2 of the N parties, if K of N parties collude, they're able to see everyone's private information. So this is not good, because we want to have the guarantees of being as long as you don't violate the protocol, you're gonna keep your privacy. So that's why I mentioned 2PC when MPC is a more accepted term. There's a lot of questions here. I see them just popping up. Test. Okay. Any use case where 2PC can be used in games? Yes, a lot. So for private, so it's where you have 2 parties where one of them has a sword and one of them has a shield, and you don't want to reveal the properties of the sword or the shield. So you use 2PC to calculate the result of me hitting someone's shield with my sword. Yeah, okay, I already answered is 2PC special case of MPC. Why not just skip to MPC? Can you chain multiple 2PCs to get MPC? Kind of, I think. This is an interesting question to think more about. Would you consider FHE with threshold to be general purpose MPC? Yeah, so I think that FHE is non-interactive MPC, and you can also have FHE where it's 2 of 2 FHE. So I think that FHE is just a special case of MPC. Let me see. How does FHE and SNARK fare against 2PC/MPC? Well, you can put 2PC in a SNARK too, and 2PC and FHE in a SNARK can be really fun. Yeah, Vitalik recently said that there are some disadvantages in MPC. Will 2PC also have them? Well, I think I was framing the 2PC as being just between you and one other person. And in that case, you can have this really nice security guarantees that override the limitations that Vitalik talked about. This is based on a true story? No. Well, not my true story, but maybe someone else's. Hey there, that's awesome. How can you get started with help with crypto? That's a good question. So it depends what you want to do. If you want to learn to do zero knowledge proofs, okay, so if you want to do theory, if you want to do engineering, if you want to do product development, there are different paths. So if you want to do theory, I think the best thing to do is to read the book or to start implementing the book Proof and Arguments by Justin Thaler. There's a lot of interesting, it goes through a whole bunch of different proof schemes, and just implementing them, it really helps to get a feel for how they work. If you want to do engineering, it seems that it's probably good to start with building some simple things with Circum, so you're able to see how it works and what kind of tool. Yeah, you can see how it works, and you can start to get a feel for some engineering questions, and probably go in the direction of proofs and arguments too after a while. If you want to do some product stuff, you can start with Circom, and you can also already build some things today. If you want to do 2PC stuff, it's like there's one or two libraries. There's MPZs. There's that library, and we're working on some like MPC or 2PC tooling that people can use. Let's see. Did you tell your best friend you love them? Nope. How do you deal with the other party lying in 2PC? Is it possible for them to lie? So I guess there's some nuance here. So, like, you could have a malicious best friend who is just like trying to just doesn't know what they're really doing, so they input that they love you, but it actually ends up being this really embarrassing kind of disappointing moment when you find out that they were just joking. But so you could lie. That is true. And there's some really nice kind of like coordination, or there's a really nice use case of ZKPs here where you can prove about things into the MPC. For example, if you wanted to do like an auction, you could prove that you have, if you want to do an auction, you could prove that you have enough money to buy the thing before you make the, before you enter the bid or whatever. But yeah, that's a really good question. I suppose that like in some of the later examples of 2PC, you could have this system where you're like, where you have to like, your AI would have to prove to the other AI that you're constantly talking about the other friend, or like this is something that's come up before. Like there's some stuff that you could do like that, but yeah, that's definitely a concern. Okay, what is the bottlenecks of ZK? Okay, let me go down to the bottom because I think wow, there's 44 questions. We'll do one more question. Okay. Hi, what are the use cases of programmable cryptography, specifically applications of ZK in math education and proof of skills? Oh, goodness, I don't know. Proof of skills. Okay, so you can definitely have like credential systems where you're able to prove that you have a certain degree or whatever. I think that you could do some kind of ZK test, which might be fun. You could do like calculate the test to some. You could like sign all of your outputs and prove that this was your output or your input to the test result or whatever. I suppose you could have some AGI that like grades your test or checks your multi-choice questions. But this is definitely something to think more about. But anyway, thank you so much. That's the end of my time. Take care.